Hello, my name is Seth Holder, and this is my Lab 4 for Physics 2212 on bar magnets. Brief overview of the lab. We are examining the effect of magnetic dipoles, understanding the distance relationship for magnetic strength, and finding the magnetic dipole moment using the Biot-Savart law. Using GlowScript, we are creating a computational model to determine the theoretical magnetic field. As a result, we can see the magnetic field of a bar magnet is proportional to the distance of b inversely proportional to r cubed, and n shows us about how much it changes as we're moving further away from the bar magnet. And we got our dipole moment to be about 7.91. These are a few of the concepts we're going to be using in this lab. First, we have the Biot-Savart law, which is a fundamental principle in electromagnetism that describes the magnetic field generated by a constant electric current. We also have the magnetic field dipole and the equation of distance dependence. For the setup of this experiment, we downloaded an app on our phone that allowed us to access the magnets within the phone and detect the magnetic fields in the area. We used the values the app gives in the bar magnet to find the center of the sensor. In this, the system is the bar magnet and the surroundings are everything else that produce a magnetic field. In this slide, we're just showing you the on-axis data we found during the experiment, the measurements we took on the left, and then the plotted data in the graph on the right. And as you can see, this is about where we got our slope from, the negative 2.5x, as you can see. These are the off-axis measurements that we got that will be used in our computational model on the next slide. This is part of the GlowScript code that was used to find all the values that were used in my code. And we use mu mag, which is an important value for the rest of our code. And the U measures the strength and orientation of the magnetic source. And M is the power law exponent, just kind of showing you how to find that. And because we're using the magnitude of it, we're not looking at a vector, we're just looking at a scalar number. And we use these codes and a bit of the code that you see later to find the dipole moment at different locations. These are some of the calculations we did of how we found our MU and just what we got from the graph of plugging in our numbers earlier. We did these calculations, gave us an M of about 7.91, which you saw at the start of the recording. Some errors and assumptions that could have happened during this lab. Sources of error, there could have been other magnetic fields in the surroundings. A lot of devices have magnets in them, and so if there was anything too close or anything we just didn't realize, it could have thrown off our measurements. An inaccurate location of the magnetometer, which is the app that we were using on the phone. If we were in a bad location, it also could have thrown off our values and given us numbers that are not accurate. Human error is always something that we gotta account for because we are all human. We can make mistakes, and we could have made a mistake when measuring distance or the magnetic field. And just some assumptions that we made is the bar magnet is acting as a perfect dipole, and the magnetic field is zero at a far enough distance. We are especially doing with this with the devices in the area, so that we could say that nothing else was affecting the magnetic field surrounding the bar magnet. What if? What if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? Our results would have been less accurate because the Earth has a natural magnetic field, and it would have interfered and superpositioned with the bar's magnetic field, and it would have caused the data to be different at different points because of the way they superposition and add together at every point in the magnetic field, and the data would have been skewed. What if you were to stick two identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? In this scenario, we are just doubling the strength of the magnet, and we would expect the n value of distance dependence to be the same, but my calculated magnetic dipole would have increased because there's an increase in strength of the magnet. And so that's about how it would have affected our results and what values it would have changed.